Hi guys, welcome to my channel. Today let's solve yet another lead code question. And like, share, subscribe if you found this video helpful. So let's deep dive into the description of the question. City is represented as bidirectional connected graph with n vertices where each vertex is labeled from 1 to n. The edges in the graph are represented as 2D integer edges where each denotes a bidirectional edge between ui and vi. Okay, great. And each vertex pair is connected by only at most one edge, so there's no two edges between any two vertices, and there's also no self loop of it. Every vertex has a traffic signal which changes its color from green to red and vice versa every change minutes, right? So if given time for change is 5, then from first 5 minutes every node will be having green light, and from 5 to 10 minutes every node will be changed its color to red, and similarly green red. So at every instant of time all the given nodes will be at the same color, that's either green or red, because that happens to every node and it's independent of one another. So they happen simultaneously. So at any given instant, either everyone will be green or everyone will be red. And we are also given that you can enter vertex at any time, right? But we can leave it only if its signal is green. Consider this as traffic light. In traffic light, if you are on a straight road, then you can come into the bulk of the traffic. If there's a red light, if there's a green light, then the traffic will be moving, right? And the second minimum value is defined as the smallest value strictly larger than the minimum value. Right, right. In 2, 3, 4, the second minimum value is 3. In 2 to 4, one may assume that it's 2, but it's given that strictly larger than the minimum value. So 2 is it's not strictly larger than 2, so answer would be 4 in this case. We are also given this, and you can go through any vertex any number of times. Okay, we can go through any vertex. That's for example 2, I guess they mentioned this. See, from 1 to 2, the minimum distance would be 1 if we consider that there's no weight in between and we are considering only hops. But the maximum count would be 1 to 2, 2 to 1, 1 to 2 again, 3. And that's the second minimum value. And third would be 5. Great. So this is a question that's given. But let me first of all change this question into one medium question and two easy questions. Let's not solve it as hard question. One may, given the first example, and I'm assuming, and specifically assuming here, assumption that there is an edge from 2 to 5 as well. For your clear understanding, I am writing this. So from going from 1 to 5, we are having three different parts: 1 to 2, 2 to 5, 1 to 4, 4 to 5, and again we can go from 1 to 3, 3 to 4, 4 to 5. So these are two different cases. Will you think that these different cases, solving them differently, give us any other result, like this would give other result and this would give other result? No, let me clear this for you. The only change between these two is node labels, but traversing from every node to every other node, it takes given time. So traversing from 1 to 2 or 1 to 4 takes only 3 minutes in the first example. And after 3 minutes, 2 also will be in green, 4 also will be in green, because every node will be in the same color at a given instant of time. And from 2 to 5, how much time would it take? It takes again 3 minutes. It also takes again 3 minutes. So in 6 minutes, we can reach from 5, either by 2 or either by 4. It won't make any sense if we consider node levels to be different, because at a given instant of time, both of them will be at the same green or red. So these two cases, I mean, solving two different cases which are having same hop count won't make any sense. So the first medium question which I am proposing over here is to find the second minimum hop count from traversing for source to this destination, right? This is the very easy and clear understanding. So one could say that I could reach from any node to any other node: 1 to 3, 3 to 4, 4 to 3 I'll go, and again 3 to 5 I'll come. But this, you assume this, that every node will be at the same color. So traversing from 1 to 2, 1 to 4, 1 to 3, 1 to 3 takes same time, 2 to 5 same time, this same time, this takes x, this takes x only. And for example, from 4 to 5, here there's an extra value added of considering waiting time and traversal time to be t. Then it would be here x plus t plus d. So you got my point. Here x would be the first smallest and the x plus t would be the second smallest. So we need to find the second minimum hop count. And that's the first medium question. And what's the way of finding the second minimum hop count? First, let me find just a hop count, and after finding the hop count, I'll tell you what to do. So ideally we would be getting here first hop count would hop count would be 2, 2, 3. Hop count would be here, hop count would be 4. It only depends upon the hop count. I mean to say that hop count is directly proportional to the time taken, given that we were at given that if for every node the signal is changed every change minute, so hop count is directly proportional to time. So we need to find the second minimum hop count. And how can I find the second minimum hop count? And the idea is really simple. So first of all, given edges, I'll try to find an adjacency list of it. So how to find an adjacency list? I'm pretty sure that how you people know what adjacency list data structure is. Adjacency list is, I'll tell you with the help of an example over here. So one is a node, and from one node, which nodes can be reached? 2 can be reached, 3 can be reached, 4 can be reached. So this is the adjacency list data structure, that we are storing a node, source node, and all the destination nodes that are possible to be reached from the source node. So I'll try to find out adjacency list, and it would be integer adjacency list. Oh, sorry, it would be adj list, and vector int would be coming here, and this would be n with empty values. Sorry, it should not be of size n, it should be differentiable. So but there will be n nodes, right? So it should be n. This is the initialization of adjacency list. Means I'm saying that just initialize one neighbors with empty set, 2 with neighbors with empty set, 3 with neighbors with empty set, 4 neighbors with empty set, 5 neighbors with empty set. I'm initializing this over here, but this is again not given in our question. In our question, we were given that 2, 3, 4 are adjacent nodes to 1. So we'll iterate over edges. We'll iterate over every. I'm sorry for that. We'll iterate over every edges, and we know that u being the source node will be edge 0, and v will be edge 1. We will write here adjacency list of u dot pushback v, and this is the undirected graph, so from v also we can reach u. Now we have this done. So now let me write a BFS call to find the second minimum hop count from source to destination node. Here I'll call it as BFS, and for BFS what I would need int n to find if destination node is reached or not. And also, if you observe one thing, we are taking 0 indexed array, but here nodes are labeled from 1 to 5. So from every node we need to subtract 1 to make it 0 labeled. So it would be I would subtract 1 over here to make it 0 labeled. And I also need adjacency list to find out traversal values and source. So what I'll do is now over here I'll keep track of the shortest hop counts with n, and I'm specifying that from 0th node to every other node initially there are no edges. And from vector int shortest 2, why shortest 2 and shortest 1 need to be maintained is shortest 2 specifies the first shortest hop count, and shortest 2 specifies the second shortest hop count from source node to every other node. And I'll take a queue to make a BFS calls, and initially inside the queue I would be having source node with hop count 0, right? Got it? Because from source reaching to source again takes how many hops? 0 hops. And now while I'll traverse through entire queue, and I'll get v and distance node to be what? Q dot front, because at the front I'll be having the pushed nodes, and I'll traverse through the entire neighbors of adjacency list of the Vth node, or I'll call it as no, I'll call it as youth node because it would be more clear, so that from U we'll go to V and it would be U only. So what I'll check is here, I'll check if the neighbor node, if what is the current distance? Let me write the current distance. Current distance from traversing from U to neighbor would be what? Dist plus 1, obviously, because till U we reached with the distance dist, and for neighbor it would be plus 1 because from neighbor we can directly go to our sorry, from U we can directly go to our neighbor. So what I'll check is, I'll check, hey, I currently am having the distance shortest one from source to me, uh, and I'm also having the current distance from source to, let me explain you this, let me explain this to you more clearly. So what I'm showing over here is from source to that node, the shortest distance. Initially, I'm assuming to be int max because I do not have any information or source of truth to be initialized with it. But now we know that we knew this condition that from traversing from source to source would take 0 hops. So I'm starting at this condition that at here I'd be going from source to source with 0 distance, and now I'll be traversing through the neighbors of it. So first I'll need to pop it out from the queue because I need to go through the nodes of it. And what I'm checking in the current distance from traversing to 2 or 3 would be what? Distance plus 1, because from 0 to 0 it would be 0, and from 0 to 2 or 0 to 3, how much distance will it be? Distance plus 1. So what I'll check is, I knew that from 0th node or one node here, because we are using 0 based index, I'm calling it, I'll subtract 1 from every node, and I'll call the node with that name 0. So this would be 0, 1, 2, 3, 4. So currently I'm saying that for first node I'm having the distance, and this is neighbor because here neighbor would be 1, and I'm now checking if my current distance is lesser than the shortest distance. So if current distance, sorry, if shortest distance is greater than current distance, I'm telling that my shortest distance that I could be reached from 0th node is in max, but that is contradiction because the current distance is 1. In that case, I obviously need to change the shortest distance, no? In that case, what I'll do is, instead of leaving it, I'll say now the first shortest distance would be the second shortest distance. Distance here is the hop count, and the first shortest distance would be current distance. And I'll tell I already traversed here, so it would be neighbor with current distance. Distance in the sense hop count, remember that. Else if I'll tell my shortest one length is less than current distance only, but sorry, and this current distance is also less than shortest of two. In that case, what I'll say, oh, my first hop count is obviously less than current distance, but my current distance is less than shortest of two. Then what I'll need to do is, I'll need to change the shortest two of neighbor, and I'll need to make it current distance because the second minimum hop count is already found out here. And here also I'll need to push neighbor with current distance. And what I'll return over here is, I need only traversing to fifth node or n minus 1th node. So I'll check if shortest to, I mean second minimum hop count of reaching to n minus 1 should not be equal to int max. If it's equal to int max, then I couldn't find such distance, then I'll return minus 1, else I'll return shortest 2 of n minus 1. So let me explain this once again for removing any confusion if you do have. So I'll need to find the second minimum hop count from 0th node to source node. What I'm saying is, from 0th node to source node, in between there are multiple intermediary nodes. Initially, I'm assuming that from 0th node to every other node, the hop count is either first hop count or second hop count is int max, because I don't know anything. But there needs to be some starting condition which we knew already, and that starting condition is from source to source the hop count is 0. So in this queue, first one would be the element itself, and the second one would be the hop count. So I'm pushing the source node along with the hop count in it, but we need to traverse to the entire neighbors of it. So I'm checking if Q is empty or not. If it's not empty, I need to traverse, and I am getting the front element of it, in meaning I'm getting the first element of the queue. Q is last in first out data structure. Sorry, first in first out data structure, meaning the first node to be entering into it will be the first node which will be exiting out of it. So I'll be getting here what I'll be getting source node, and I'm getting the source of truth or hop count to be 0, and I'm popping it out because I already traversed to it. And what I'm saying is neighbors of adjacency list of u. What are all the neighbors? 2, 3, 4. So if now I already specified earlier that shortest path from 0th node to 1 node is int max. But now from first node to second node, how many hop counts will it take? The hop counts that are taken to reach from to 1, and then again from there to 2, it would be 1. So it would be the distance and plus 1, because plus 1 to traverse from 1 to 2. So I'm checking that my original source of truth or original value is shortest one of 9, and that's greater than current distance, which should not be the case. In that case, what I'm saying is my shortest 2 will be having shortest 1, and my shortest 1 will be replaced with the current distance, because that is the smallest I can find. And shortest 2 is being changed here. That's the reason being, earlier shortest 1 was the minimum hop count, but I already find the minimum count, so this would be the second minimum. So second minimum should be stored in shortest 2. And here if it's my current distance is already greater than shortest 1, but it's less than shortest 2, then my shortest 2 would be the current distance. And here I'm just checking out if n minus 1 can be reached or not. If it couldn't be reached, it is minus 1. If it can be reached, then it would be the second minimum hop count returning over here. Now I'll need to check it out if it's working fine or not. So I'll first return bfs of n adjacency list and current, n adj list and current. What's the current? Current would be 0, right? Sorry, source would be 0, right? Let me run this now. What I need to get here is 1 2 3. 3 should be the minimum hop count. Acha, this should be q dot empty. I'm sorry for that. Right, it should be 3, and it's 3 as expected. Here also it should be 3. Remembered, from 1 we'll go to 2 in one hop count, 2 to 1 second hop count, 1 to 2 again third. So it should be 3 over here also. Right, it's working fine. So we are done with the first medium question. We already found the BFS. And let me write it. Hop count is equals to BFS of n ADJ list and source is 0. Now let me explain you the second easy part of it. So see, from given we are having change minutes. So from 0 to 2 minutes, everything will be in green. If given here change is 5, so from 0 to 5, everything here would be green. From 5 to 10, everything would be red. From 10 to 15, everything here would be green. From 15 to 20, everything would be red. So you just think of it that if given any instant of time, which factor decides whether we need to move or whether we need to stay. Suppose I am given a time 16. I'm telling that at 16 units I reach this node. So should I move or should I stay? The answer is I should stay here, because from 15 to 20 the light is red, so I need to stay here. And till what time I need to stay? I need to stay till 20. So what would be the waiting time at that node? It would be 20 minus 16, which is 4 minutes. So can you think of any algorithm over here that specifies whether we need to stay or whether we need to move? The idea here is really very simple. Again, that's binary search, because if I'll find the multiple of change which is previous value. So in turns, I need to say that if I were given 16, I need to deduce 3, because 5 into 3 would be 15, and that would be the cap for 16. Similarly, if I'll be given 18, I need to find 15, because for 18 cap is again 15. So what I'm trying to say is, given any value and change time, that is 5, I need to specify the lowest multiple of it, or the index of it, where it's the lowest multiple. In other terms, let me say with the help of example only, given 6 and given 23. I knew that 6 into 3 is 18, given change time is 6, and given current value is 23. I knew that 6 into 3 is equals to 18, and 6 into 4 is equal to 24. Then I need to return 3 from it, saying that it would fall under 8 into 24. 8 into 24, here 0 to 5 is nothing but 0 to 5. I could indirectly return like this, right? 5 into 0 to 1. Similarly, the below case also, from 5 to 10 as well, I can write this way. If you people are okay with it or not okay, it's fairly simple. I'm just commoning out 5. I'm commoning out change 10. Here again, it would be 2 to 3. So my second simple problem which I specified is just finding the binary search, and binary search is fairly very simple algorithm having our given condition. So I'll make it private only because I do not need to expose it, and I'll call it binary search. In binary search, I'll be having low values, high values, and this is the value that I was given, either 22 or 23, and this is the change. I'm calling it change only. So binary search will be, this is a base condition, right? Low should always be greater than or equal to height, and I'll need to find the minimum. How can I find the minimum? Low plus high minus low upon 2. What I'm checking here is, I'm checking the simple one is, if mid is the current multiple into the change is greater than value. What I'm telling is mid into change is greater than value. So we already reached the cap of our index, and now traverse to the left half of the array. Else I'll say traverse to the right half of the array, and we'll return low value at the last. So we'll also need to check this out. So here I'm returning int count 0, 1e5. So till 1 into 5, 1e5. So till change into 1e5, I'll be traversing this. Value currently is 22, and I'll use 8 here. Then what I need to return? 8. The value which I need to return here is 2, because 8 into 2 is 16, 8 into 3 is 24. 8 into 2 is 16, 8 into 3 is 24. So I should be returning 2 over here. There's no count. Achha, that's binary search. What I'm getting over here? I'm getting 3, but it should not be 3, it should be 2. Why am I getting 3? Rise. I'll need to reduce 1, because low would be, we are checking low is less than or equal to high, no? So low exactly would be high plus 1 in that case, so we need to return low minus 1. In the similar way, if it's 15 and I gave it 7, what should I be getting? I should be getting 2, because 7 into 2 is 14, 7 into 3 is 21. 14 is less than or equal to 15 is less than or equal to 21. In that equality, left index should be 2. Here if I gave 57, then I should be getting 8, because 7 8s are 56. Now one may ask me, what's the exact logic of finding this, that they may not be clear of it, right? I'll explain you this also. Given a time, we knew that if the left value of it is multiples of 2, then we'll be having green light and we could move. There would be no waiting time. But if it's odd multiple, or if it's 1, 3 or something, then we need to stop over there and there will be waiting time, right? Fairly simple. So I'll do that for every hop of it. I mean, I'll do that for every node of it. I'm storing the binary search value in BS, and I'll cap my maximum values, or caps maximum multiple still 1e5, because 1e5 into change would be too large, and I don't think that there would be these many instances which exceeds 1e power 5. So I'm capping it till 1e5. And here for binary search, So current value would be 0. Binary search would be starting from low, will be going till high. Uh, Value is value, which is current value, and change is change. So here I'm checking at the very starting what would be the my left index of it. So I'll be starting at 0 only, and at 0 everything would be green. So I'll check here if bx percent 2 is equal to 0. Not equal to 0. I'm checking if it's odd multiple. If it's odd multiple, then what would be my waiting time? So if my current time value is for example 7, what would be the my waiting time? Int waiting time would be, I'll need to multiply change with bs plus 1, right? The example is here only. Change is 5 and I'll need to multiply it with index plus 1. So it would be 10 minus what's the current value. From that value, I'm waiting till that time. So it would be change minus value. And I'll need to add time to the value, and I'll just return the value. I'll also need to reduce the hop count by 1 after my loop. So I'm getting 9 over here. I'm not sure what's the reason for it. What what am I getting over here? And it's 9. Uh, Let me check this out. Why is this happening? Oh, the reason here again is I forgot to add waiting time to my value. It should ideally be added because I waited till that time in the given node. I submitted this out. It's more than 82% of it. We bet that many people, and it's easy, fair enough. So if you're okay with it, then it's fine. If you're not okay with it, just add me the comments wherever you're hashtag, and I'll explain it more clearly. Coming to this hop count, I guess it's fairly enough because we already discussed this 2 times. And this binary search part also, I'm assuming that it's already clear because I explained with the help of an example that from 0 to 5, everything would be green. From 5 to 10, everything would be red. So this example only let me consider. We'll be starting at time equal to 0. So the binary index, which is to the multiple of 5, will be giving us 0, index 0. So we are checking that if it's not equal to 0, then there will be waiting time. But if it's equal to 0, then there won't be any waiting time. So we are simply adding time, specifying that we already reached to the second node with this given amount of time. And for example, in the first case, it would be 3. Uh, Let me explain with the help of first case only. Hop count in the first case is 3, and time to take to reach to other node is also 3, and waiting time is 5. So hop count is 3. That's fairly simple. And in binary search, I'm checking first one will be 0 only because 0 to 5 left half only I'm getting. So 3 is between 0 to 5, so I'll get 0. So sorry, 0 is between inclusive of 0 to 5. 0 is from 0 to 5, so I'll be getting 0 as the index, and I'll be proceeding further. Now my value would be 3. 3 is also between 0 to 5. Then also there won't be any waiting time. So again value will be 6 now. But once it's 6, my left arrow will be 5, or left part will be 5. And from 5 to 10, I knew it should be red. So index would be 1 in this case. And if it's 1, I knew there will be waiting time. In that waiting time would be change. What's change? 5 into my left half would be 5. So the cap of it to the right half till which I need to wait should be bs plus 1. That's 10. And my current time is 6. So I need to wait 4 more minutes. So value will be plus or more equal to waiting time. That's the question for today. Thank you.